Okay, thank you. Thanks, Tanya, for the introduction. And hello, everyone. This is Minghan from China, and I'm from the CES Quantum Network Company, which is a company who built and operate the quantum communication network in China, which is the largest one, and probably the largest one in the world so far. And today, it's my great honor to be invited here to share the development of China's quantum communication network and also the progress of the standardization. And speaking of the quantum mechanics, I think it's quite a fascinating and paradoxical science because it's very old but brand new at the same time. I say it's old because the quantum mechanics has been celebrated for more than 100 years. In fact, this year, 2025, is declared by the United Nations the International Year of Quantum Science and Technology. And in the past century, it really shaped our daily life. It behind the laser in our communication system, it behind the semiconductor in the computer, and also in the MRI in the hospital. But at the same time, when we talk about quantum, it still sounds like a future technology. It's still inspiring the imagination for the science fiction writers, and we can treat it as a technology promised to reshape the communication, the sensing, and the computing. Especially the idea of harnessing the superposition and the entanglement to achieve the exponential computation power, which really captured the whole world's attention. The leading global company like the IBM, the Google, and the NVIDIA spend a lot in the quantum computing. So that's the whole thing so far. And today, this is the outline of my talk, and I will give the presentation, introduce some progress of the network in China and how we use it, and also to introduce the progress in the standardization in the ISO IEC and the ITU. And in the 2022, the Nobel Prize in Physics rewarded to the Alan Aspect, the John Classer, and also the Anton Zeilinger for their excellent job in the quantum entanglement. And their achievement paved the way for the new technology, including the quantum communication, the quantum network, and also the quantum computers. And just after 3 years, the Nobel Prize was awarded to another 3 scientists for the quantum computing. So based on this benchmark, we can tell that there's a trend that the quantum mechanics is moving from the fundamental theory to industrial application. Ultimately, it will be really useful in our daily life. And ultimately, we will achieve the quantum internet because we will have the general quantum computers, and they will be connected by the networks. So at that time, the quantum internet is a global system that transmit, process, and store the quantum information by interconnecting the quantum network node. And the first step is the QKD network. And in the quantum internet, there are 3 important components: one, the quantum communication, the quantum computing, and the quantum sensing. In fact, these 3 technologies help each other. They enhance each other. For example, in the quantum sensing, the advantage of quantum sensing is accuracy, and it can detect a single photon. And the single photon detector is also very useful for the quantum computers and also the quantum communications. If we want to build the wide area quantum communication network, we will need a quantum repeater. And that is a very core component of the quantum computers. And once we have the quantum computer, we have the superpower to calculate, to deal with the data from the quantum sensing and the quantum communication. So that's the general relationship between these 3 technologies. And now throughout the world, the Euro and the US also published the document for the quantum internet. In 20 I remember it's 2024, the Euro published the Strategic Research and the Industrial Agenda 2030s. It gave the six stages of the quantum internet. And we can tell the first and second stage, the trusted repeater and the prepare and the measurement, it is exactly the QKD network can achieve. And in 2020s, the United States released the quantum internet blueprint by the Department of Energy. It gives the 5 milestones of the quantum internet. And the first one is prepare the measurement quantum network. So these are the two landscape towards the quantum internet. And they have a consensus that to achieve the quantum internet is not only a scientific task, but also need strong collaboration with the industrial and also the companies and the whole societies. Now throughout the world, different countries have already taken the actions. Like in Europe, they have the Euro QCI is a very huge, very huge project, and the 27 member states start to build their own QCI. QCI means the quantum communication infrastructure. And finally, the national QCI will be connected together to achieve the Euro QCI, which will be more than 40,000 kilometers and have the satellite. And according to the published document, they will achieve that before the 2020s. And besides that, Japan also released the quantum network in 2011. And in Korea, they have the quantum QKD network and already provide a service for the government, and also the UK and the USA. And in China, we also have the plan for the quantum network, and it will have the evolution towards the quantum internet. And so far, at the first stage is the QKD network. It's kind of a consensus throughout the world. The first step is the QKD network. And we thought, what's the fundamental function of the quantum network? And we think, from my perspective, for the first stage, it's the network to transmit the symmetric random number. You can use the random number as a key to encrypt the information. Then it can be used in the data center or the blockchain, the ICT stuff. And in the next stage, we will update it into a quantum sensing network. And the most enabling technology is the time frequency synchronization. And at that time, the network is transmit the frequency signal. And if we, to achieve the time synchronization, if we can make every node of the network to have a very accurate time signal, then they can do the interference measurement and to sense the vibration around the network. So that's the second stage. And ultimately, we can do the entanglement photon around the network. And at that time, what the network fundamental function is to transmit the spooky action that's proposed by Albert Einstein. If we can have the entanglement relationship between the different nodes of the network, then we can do the distributed quantum computing, distributed quantum sensing. So that's the whole understanding of the quantum network. And the best part is we can use the same fiber resources in different stage. And so far, this is the quantum QKD network. We call it China's Quantum Communication Network, the CNQCN. And we just published the paper this year. And now it have more than 10,000 kilometers and 145 backbone nodes, and cover 17 provinces and 80 cities. And also we have one quantum satellite, Jinan-1, and the 6 ground station on to do the space-to-ground QKD network, QKD. And this is a very special routine we choose from the CNQCN. It's from the northmost point to the southmost point, from the Harbin to the Shenzhen. And it is the longest backbone of the CNQC, and it have more than 4,600 kilometers. And we divided into 4 segments from A to D, and we can tell the different part of the link have the different SKR, the secure key rate. And in the quantum network, the end-to-end SKR is determined by the minimum SKR, and we can consider the key rate and to arrange the different service in the different regions. And this is the some use case of the network, and the very typical one is we use the quantum network to provide the key services to the financial. This is provide the service to the People's Bank of China, and they have 3 data center in Beijing, Shanghai, and Wuxi, and we provide the 3-level key system for them. And the local master key is kept by the users itself. And what we give is the communication master's key and also the working key. Working key is from the quantum random number generator, and it is encrypted by the QKD keys from the quantum network, from the backbone networks. And then this is the second scenarios for the offline terminal, which is the smart cell phone. In China, we have the China Mobile and also China Telecom to provide this kind of services. The QKD keys can be stored in the SIM card of the phone, and when they make the phone calls, the information will be encrypted by the quantum power. And not only the phone calls, but also the message and the video meeting will be encrypted by the QKD keys. And so far, we already have more than 4 million users. And then I will introduce the overview of the progress of the standardization. And we can tell, if we do to do the overview of the quantum standardization, we can tell it can be divided into 3 stages. The first one, at the very beginning, the ETSI, the ITC starts very first from the 2008. And at that time, the QKD market is not ready enough. So at that time, the standards mainly focus on the QKD device itself. And it published the 13 standards. And so far, it's more than 20 standards, but at the first stage is like 13 standards, focus on the QKD use case, component, and the interface. And the second stage is from the 2019, the ITUT start to do the standard research about the QKDN, the QKD network. And it developed, so far it's more than 40 standards, and it cares more about the architecture of the QKD network and the functional requirement and security management and the interface protocol. And very recently, in last year, the IEC ISO just established the new JTC3, and the scope is enlarged to the whole quantum information technology. And this is at the very beginning. We have some, we just established some working group, and some TR is under study in the JTC3. And for the ITUT, China promote to establish the first focus group about the quantum information technology. In 2019, the focus group called the QIT41, it means Quantum Information Technology for Network, is established. And it finished in 2021, and then the JCA of the QKDN established. And in the ITUT, there are 3 study groups do the research about the QKDN. The SG11 is about the protocol and the interface. SG13 is about the network, and the SG17 is about the security. So far, we have around 40 standards in different 3 study groups, and for those standard works, mainly have the collaboration between China and Korea and also the Japan. And for the JTC3, it is established in the 2024, and because the Korea member is the secretariat, so the first meeting, the established meeting, is held in Seoul last year. This is the picture of the first meeting, and in that meeting, it set up 6 ad hoc groups, and to provide a platform to all experts to have the discussion what are we going to do and what's the scope of the different ad hoc. And second meeting is in the October of 2024 in Edinburgh in UK, and in that meeting the scope of the different ad hoc is more clear, and some NP is proposed by the different countries. And in this year, in Tokyo, we have the third meeting. And in this meeting, the plenary meeting approved to establish the 5 working group, just like this slide. And so far, we have 2 ad hoc groups and 5 working groups. And the working group 13 is about the QRNG, and I'm the commander of that working group. And so far, it's still in the ad hoc group, they have the discussion to talk about whether we need more working group and what kind of proposal it can be discussed in the plenary meeting. So it's at the very start of the standardization work, and also welcome for all the countries to join us and to do the contribution to different working groups. So last but not least, I will give a brief introduction about our company. Our company is called CAS, means Chinese Academy of Science, Quantum Network. And we built the QKD networks in China and also operated it and in the 2016. And the technical is from the academician Jianwei Pan's team. And so far, it provides services of quantum technology and the ICT, including the quantum cryptography and also quantum safe cloud services. And this is the link of the website. If you have interest, you can search it. And in the last, I would like to thank the organizer to give us this platform to do the communication, which is exactly the quantum industrial need right now. Okay, thank you.